Have you seen OpenAI's Figure 01 demo yet? It's mind-blowing. But there's this cool tech called multimodal models that helps robots like Figure 01 understand the world better. I'm curious, how exactly does that work? Let's unravel this mystery together and see how robots are becoming more intelligent and in sync with our world. Imagine this. You're at a bustling street market filled with sights, sounds, and aromas. Everywhere you look, there's a riot of color, from the vibrant fruits to the vivid attire of the shoppers. You hear the clamor of vendors advertising their wares, the chatter of excited bargain hunters, and the distant hum of city life. The air is rich with the scent of freshly baked goods, fragrant spices, and the unmistakable aroma of street food. As humans, we naturally take in all this sensory information, processing it simultaneously to understand and navigate our environment. This ability, so intrinsic to our human experience, is something we might take for granted. But now, imagine if a machine could do the same, process multiple types of information at once. Welcome to the world of multimodal models. I appreciate it if you could subscribe and like the video. Now, let's understand the language of data. Data speaks in many languages: images, sounds, text, and more. Just like how we humans use our senses to understand the world around us, machines too need to interpret a variety of data types to make sense of their surroundings. This is where multimodal models come into play, serving as the polyglot of the computer world. Think about it. When we encounter something new, we don't just rely on one sense. We look at it, touch it, maybe even listen to it, and all these senses combined give us a holistic understanding of the object. Similarly, multimodal models help machines comprehend their environment by interpreting different types of data simultaneously. Imagine a robot in a factory, tasked with identifying various materials. A single modality model might struggle with this task if it only uses visual data. After all, many materials can look similar. But what if the same robot could also touch and feel the materials? Sounds like science fiction, right? But it's not. A multimodal model can integrate visual data with sensor data from the robot's touch to distinguish between materials more accurately. In essence, a multimodal model is like a super translator, capable of understanding and translating multiple languages of data into a form that machines can act upon. This comprehensive understanding allows machines to interact more effectively with their environment, make more informed decisions, and ultimately perform their tasks better. So, just like a polyglot who speaks many languages, a multimodal model can understand many types of data. In the following scenes, we'll delve deeper into the mechanics of these models, their advantages, and how they're changing the world. Stay tuned. So, how does a multimodal model work? Excellent question. Think of a multimodal model as a well-coordinated team, where each member plays a crucial role. This team is made up of specialists, and each specialist is an expert in a different type of data. One might be a whiz at interpreting images, while another is a pro at deciphering sounds. Yet another could be a guru when it comes to understanding touch sensor data. Now imagine these specialists are in a meeting, each one sharing their insights. The image specialist might say this object looks like a ball, while the sound specialist could add, it sounds hollow when tapped. The touch sensor specialist might then contribute, it feels smooth and round. But who's leading this meeting? Who's making sense of all this information? That's where the central hub comes in. You can think of the central hub as the team manager, combining the findings of each specialist to form a comprehensive understanding. So if we go back to our ball example, the central hub would compile all the information and conclude, this object is a hollow, smooth, round ball. In essence, a multimodal model works by breaking down different types of data, interpreting each one separately, and then bringing it all together. It's like a well-coordinated team, each member contributing a piece to the puzzle. And that's the beauty of multimodal models. They leverage the strengths of different data types to create a more complete, robust, and accurate understanding of the world. So next time you see a robot navigating a cluttered room or responding to voice commands, remember the multimodal magic that's making it all possible. But why go to the trouble of creating these complex models, you may ask? Well, the advantages of multimodal models are numerous and significant. One of the biggest benefits is the increase in accuracy. Just like how adding pictures to a book can enhance our understanding of the story, adding multiple sources of data can drastically improve a model's understanding of its environment. By considering multiple modes of data, images, touch, sound, even smell in some cases, these models can create a more comprehensive and precise picture of the world. Imagine trying to find your way around a dark room. You might stumble and bump into things if you rely only on your sense of touch. but if you could also hear, perhaps the sound of a ticking clock or the hum of a fridge, you'd have a much better idea of where you are. This is essentially what a multimodal model does. It uses all the available senses to make sense of its surroundings. Another advantage of multimodal models is their robustness. In the world of AI, robustness refers to a model's ability to perform well, even when conditions aren't perfect. A traditional model might falter if the quality of its input data is poor, or if it encounters a situation it hasn't been trained for. But a multimodal model with its multiple sources of data is more likely to soldier on. It's like having a backup plan. If one source of data fails or is unclear, the model can fall back on the others. Moreover, multimodal models are highly adaptable. They can be applied to a wide range of tasks, from autonomous driving to virtual assistants. By understanding multiple forms of data, these models can interact with the world in a much more human-like way. So, to put it simply, the trouble of creating these complex models is well worth it. The benefits they offer in terms of accuracy, robustness, and adaptability make them an exciting frontier in the field of artificial intelligence. With multimodal models, it's like having extra sets of eyes, ears, and even fingers all working together. Enough theory, let's see these models in action. First, let's talk about traffic control. Imagine a world where self-driving cars lead the way at intersections, signaled by a simple white light. This isn't a far-off dream, but an idea proposed by civil engineer Ali Hajbabaye. Using vehicle-to-everything communication technology, Hajbabaye's system could reduce travel time and fuel consumption. And the best part? Even with just 10% of cars being self-driving, we could already see these benefits. This is a fantastic example of how multimodal models can revolutionize something as everyday as traffic flow. Next, let's visit the exciting realm of robotics. Big tech companies are now developing artificial intelligence brains for real-world robots. Consider Google's PaLM-E, a large language model with a staggering 562 billion parameters. PaLM-E can perform tasks like math reasoning, multi-image reasoning, and chain-of-thought reasoning, all by combining language and vision capabilities. By integrating this model with robots, they become more autonomous and efficient. A robot with multimodal learning can understand high-level instructions, answer questions, describe images, and even plan actions. Finally, let's look at the industrial sector. Industrial robots have already transformed manufacturing processes, but their widespread use is often hindered by complex human-to-machine interfaces. Enter multimodal models like ChatGPT, which enable robots to understand natural language commands. This not only improves efficiency, but also fosters better collaboration. By generating robotic programs from natural language descriptions, these models simplify programming and onboarding processes, a boon for industries worldwide. As you can see, multimodal models aren't just theoretical, they're making a real difference in our world. So where do we go from here? The future of multimodal models is a thrilling prospect. As we've seen, these models have the potential to revolutionize the way machines interact with the world, making them more autonomous and efficient. But what's on the horizon? Let's take a peek into the crystal ball. Imagine a world where self-driving cars navigate traffic with ease, where traffic lights are a thing of the past because vehicles are communicating directly with each other and the environment. This isn't just a pipe dream. Engineers are already working on ways to integrate self-driving cars into traffic control systems using the very principles of multimodal models we've been talking about. And it's not just about cars. Large language models like Google's PaLM-E are being adapted for robotics, combining language and vision capabilities. This enables robots to complete tasks in the real world autonomously, making them more efficient. The ability of these models to transfer skills across tasks, reason over multiple images, and generate high-level instructions is a game-changer. In the industrial sector, multimodal models could enhance the efficiency of robotics. By enabling robots to understand natural language commands, we can improve collaboration and simplify the programming process. There are hurdles to overcome, of course, such as representing the physical world accurately and ensuring safety. But the potential benefits are immense. Looking further ahead, multimodal models could lead us closer to artificial general intelligence, where machines can understand and learn any intellectual task that a human being can. It's a lofty goal, but one that researchers are fervently pursuing. Alongside these exciting developments, there are challenges to face. As with any technology, there are societal norms, regulations, and power dynamics to consider. We need to ensure that the benefits of multimodal models are accessible to all, and that they don't inadvertently widen social inequities. The future of multimodal models is exciting and full of possibilities. Stay tuned to see where this journey takes us. We've covered a lot of ground today. From the basics of multimodal models to their real-world applications and future prospects, we've seen how they're revolutionizing the realm of artificial intelligence. We began by understanding that multimodal models are like super translators for machines, enabling them to understand the languages of sight, sound, and touch all at once. This gives them a more comprehensive understanding of the world around them, making them more effective and efficient. We then delved into the mechanics of these models, which work like a team of specialists. Each one focuses on a different kind of data, and their findings are combined to form a complete picture. This process allows machines to understand and interact with their environment in ways that were previously unimaginable. We also looked at the advantages of multimodal models. By using multiple sources of information, these models can navigate and function in complex environments with greater accuracy and robustness. This capability is opening up new possibilities for robotics and AI applications in various sectors. We also discussed real-world examples of multimodal models in action, from self-driving cars to industrial robotics. These examples show us that the future of AI is not just about more data, but also about better and more diverse data. Looking forward, we can expect to see even more exciting developments in this field. As AI continues to evolve, multimodal models will play a crucial role in enhancing machine learning capabilities, transforming industries and our daily lives. But remember, this is just the tip of the iceberg. The world of AI is vast and ever-evolving. There's so much more to explore and learn. So, I encourage you to dive deeper, ask questions, and keep your curiosity alive. Remember, the world of AI is vast and ever-evolving, so keep exploring, keep learning, and I'll see you in the next video.